I got a full room here. Yay. Welcome to this session on the Azure Service Fabric. Now, the cloud has helped us with a lot of stuff. The thing we want to do is the stuff on the left, right? Or the thing on the left, I would say. And then we wind up with all of these other things that we also really want our application to be able to do, to have these capacities. But we want to be happy blue lipstick guy, right? We don't want to be sad goatee gentleman, right? So that's what we want to solve, all of us, and we all want to solve the same problem. I think the mic sound is a little loud and echoey. Thank you. So this and lots of more stuff are things that are production concerns. Things that we need to do, things that we need to set up, things that we need to worry about and have sleepless nights about, and so on. And in this session, I'm going to cover, hopefully real quick, what a microservice is. And then we're going to talk as much as possible about the Azure Service Fabric. And some people have called the Azure Service Fabric PaaS v2. And some people have called other things PaaS v2. I don't mind, which it doesn't matter much to me. But I want to ask you guys first. You, the awesome, huge audience in this room, by the way, wow, have you guys got anything? First of all, I would assume you guys have Azure subscriptions. Yes, I have an Azure subscription. Yes. I have something in Azure in production. Yeah, well, it's about half the room. And also then Service Fabric. Have you had a look at it? Anyone? I've looked at Service Fabric. Well, there are several. Oh, interesting. So it'll be interesting to see what you actually learn from this session. This is, in order, in the interest of setting expectations, this is going to be an overview. It's going to be kind of introductory. And if you guys want to have a chat about specific things or specifically, experiences, what type of experience do I have using it, we can continue our talk after the session outside as well. Anyway, I'm Magnus Mårtensson, I guess, and assuming that you know this because you've probably read the schedule, the speaker bio. I run my own company in Sweden called LoftySoft, and I'm down here for the first time on the Southern Hemisphere, so yay. It's awesome to be in Sydney. I'm an Azure MVP since many years, and I'm also a regional director up in Sweden, which means that I'm a very close buddy with Microsoft since many years, and I've been hanging around their space. So I just want to point out that this is the official Microsoft slide showing how many customers are looking at the Service Fabric, and my company logo is right there. So, I just wanted to mention that. Before we go any further, I also want to say that I'm a big community guy. I love community stuff, and I hope you all have heard about this event that we run each year. There's going to be another one in the spring of 2017. It's the Global Azure Bootcamp. Anyone can host a community event on the specific day that we will announce, to be announced. And then on the same day, all of these locations together run Azure events. And we usually do some kind of a global lab together that sort of connects us all. So it would start over here in the Sydney timeframe in the morning. And Sydney locations and thereabouts would do their thing for the day. And roughly when they start to close out, I guess the India locations are starting up, and then Europe and so forth. So from one end to the other over here in Honolulu, we run the event in about 30 hours, continuously running across the world. It's pretty awesome. I just had to point that out because I'm a community guy. Let's talk about microservices. It's kind of the new black, right? The new black of software architecture, I would say, currently. It's one of the big trends. So, relatively quickly, let's just decompose this thing, because that's kind of what it is about, isn't it? Decomposing stuff. We used to have a monolithic application package that we take all the things that we need to do, package it together, and deploy it on a single machine. And if we need to scale that out, we put a load balancer in front of it, and we deploy the same package to multiple machines. If I need to go and make a small change to a small thing inside of this package, I have to make the change and build a whole new package and deploy that to all of the machines. So it's a monolithic application. There's nothing really bad about it. It works fine. But the trend, of course, with microservices is to decompose that thing into itty-bitty pieces. Or they don't have to be specifically small, but decompose the monolith into small chunks. And then create a cluster of machines and deploy actually multiple instances of your microservices onto that cluster. And that's what Microsoft has done with the Service Fabric. So very, very quickly, some of the basic facts about a microservice. Logic and state, that is independently versioned, deployed, and scaled, is a microservice. It has a unique name, so you can address it, you can talk to it, you can look it up and talk to this thing. Not all microservices, of course, are responsive to outside connections, but they have an address anyway, they have a unique name. And it can interact with other microservices. So I'll give some examples of that later. Also, of course, it has these capacities. It's consistent in the presence of failures. There's, it runs somewhere in an environment where it can fail over and start over and do things like that. So that means that we host this microservice thing inside of a container of some kind. And typically, a small engineering team builds one thing. So let's do an example of that. The Azure SQL Database service that many of us obviously probably runs, right? That runs as, it's built as a microservice thing, where you can imagine that there's, for instance, a little team that builds and takes care of the provisioning of new databases. That's a microservice, setting up a database. Now, they can make changes to the database setup, how to create and provision a database. They can make changes to that process and deploy that part of the SQL database service independently of all the other parts. Microsoft has a lot of these instances, your instances of databases running in the Azure cloud, right? And each instance is an instance of a microservice, each one of your databases, right? So that's another microservice, maybe the engine of the database service. So you can see how you can decompose the whole big thing into smaller pieces. And it's important to note that anything that runs inside of this container, anything that runs inside of this cluster of machines is a microservice. It doesn't matter what it is. As long as there is something that runs, that's a microservice. Now, Microsoft has built the Microsoft Azure Service Fabric. It's a funny name. I'll tell you about that later. But it's called the Microsoft Azure Service Fabric, and it really is a distributed services systems platform that makes it easy to build scalable, reliable, low latency, and easily managed applications for the cloud. This means that you can focus on your business needs and let Service Fabric take care of ensuring your application is always available and scale. So it sounds really good, doesn't it? Sounds pretty. Let's have that. If you position the Service Fabric, it's positioned as a platform service, and it's very close to a cloud service. How many has used an Azure cloud service? How many used an Azure hosted service? A few remember that. That was the first name of the cloud service. When it came out, it was called a hosted service. So you guys have been around for a while in the Azure cloud. So it also shares a lot of things with the containers world. Containers is also about clustering. So they have some commonalities here, but I would position, and usually you position containers and VM scale sets and such things in the IaaS bucket. But scale sets is the thing that actually makes IaaS more PaaS. So it's sort of this line here is starting to blur. But the Service Fabric is very close to a cloud services thing. So that's why some people have called it PaaS v2, because cloud services would have been PaaS v1. All right, cool. So that's where we're at with this. If you have any questions or thoughts or personal attacks, you stop me and let's go through that straight away, right? So Microsoft believes that PaaS provides the best foundation for creating, running, and managing custom applications, said Microsoft back in 2010. And it's kind of interesting because those of us who know, we remember that back in 2010, Microsoft didn't actually have an IaaS offering, right? So they would think that PaaS was the best way to do it, wouldn't they? Right? That makes sense. So let's update this by getting a quote from this gentleman. Anyone know who this is? Rosinovich. A for the day, sir. Thank you. The Azure CTO Markers said in January, infrastructure services IaaS like compute, storage, and networking defined the first generation of cloud computing adoption. Many organizations are increasingly turning to platform services, PaaS, to create and deploy applications more quickly. And here's the killer quote. I call this the shift from infrastructure to innovation, and it's underway today. So that's what we're seeing. We don't care about infrastructure. We don't care about VMs even. We care about applications and maybe in the form of microservices. That's what we're looking at. That's what the lay of the land is. Now, Microsoft has run a version of the Service Fabric for a good long time. It's funny that, I actually have to update that to over 6 years now, probably. And it would coincide very well with that quote from 2010, right? So Microsoft themselves had this challenge with what they call internal customers, right? To solve this same problem over and over again. Each one of these needed to attack and solve the same problem. So they started building something which is now has been rebaked to a public product, which is the Service Fabric. So they have things like Azure SQL Database, the example that I started out with, right? Probably this number is probably low now. This slide is like a year old or something. Bing Cortana allegedly runs on something like at least 5,000 instances over 3 data centers at the same time in a big cluster. And you have Azure Service Bus. I asked Clemens Vasters if I could put that up there, and he says, yes, that's mostly accurate. The Service Bus runs on something very similar to the Service Fabric, but it's not exactly the same thing, but it uses the same concept, the same technique. So this is something that Microsoft has done for years. And things like the DocumentDB is born and bred in the cloud. It started out in the cloud, and it's never been anything else but a microservices construction running in the cloud. So this is big. This is huge. When we're talking about Microsoft and microservices, there are 2 flavors. There's a stateless and a stateful version. And some microservices, if you hang around microservices, some people sometimes might argue that a microservice is stateless. So what is a stateful microservice? Doesn't make any sense. It's wrong, But there is a really good case to be made for a stateful microservice, and I'll talk more about that. Now, a stateless microservice is very close to a cloud service, right? It has state, but that's persisted on some sort of external storage, such as an Azure database or Azure storage or similar. So the process, the microservice instance itself, doesn't really have any state. And it can be lots of instances, and this is very, very similar to a cloud service instance, a web or a worker role in a cloud service. It's extremely similar to that because we've been taught, if you probably know, that a cloud service instance should not have state itself. You have local disk, but it's not the same thing. It's not persistent. It's not durable. A stateful microservice, though, is something that offers reliability of state through replication and local persistence. And I'll show you this. And it means that the cool thing about this is that this will reduce latency in your application, and the complexity and number of components in a traditional 3-tier architecture will go down. So let's quickly look at a traditional 3-tier architecture. Many of us have seen this. Many of us have built this, and I build them as well. There's absolutely nothing wrong with this picture. It's beautiful. And then you have your storage. And if you need to store lots of data for lots of different instances, you might want to scale your data tier, and that's a challenge. Then you might want to defer some work from the front end to the back end. You might start using something like a queue. In this case, it's an Azure storage queue. To get lower latency with the storage tier, you might introduce some caching at some level inside of your application, right? And also, it's quite common that work starts to become sort of workflowy, right? You do one thing and it sends another message to another queue, and some other thread picks that up and does the next step and so forth, and you get your internal workflows going inside of your application. And as you can see with this picture, which is, this is a brilliant picture. I've built systems like this. I'm sure you all have, right? What you can say about it is that it has a lot of moving parts. Each one of these things can, fail individually. They need to be maintained individually. You need to know how the whole thing hangs together, and so on and so forth. So it has the disadvantage of complexity. Still, it's a solid architecture. As a stateful microservice architecture, it could look something like this instead. Now, the state that used to be in the database has jumped into this compute middle tier here, and the instances of this state is a first-class citizen. And that means that if you need to perform some calculation based on some data here, the reads, the latency to access this data is extremely quick because it's in the process. It's right there in memory or on the local disk. So it's going to be really fast. And again, first-class citizen, so you can scale out this state without having the normal complexity sometimes of that scaling out your data tier thing. And with built-in transactions, which I will show you later. So this architecture could solve the same problem, and as you can see, it has very many fewer moving parts, so it would reduce complexity in this scenario. Cool. But of course, you would use data stores for analytics and disaster recovery and all those kinds of things as well, so they don't go away. But you know, hopefully you can do your working stuff with data that is in memory. Any thoughts or questions? Is that about accurate, you think? And those of you who know? Yeah? Thanks. Cool. So this is a bit of an older picture, but I keep it around because I like the fact that, you know, if you want to build something like the Service Fabric or Akka.net for that matter, right, the other similar thing that has been presented here at the conference, all you need to do is build that, and then you're done, right? So Microsoft built that for us, and let's focus on the lower part of the screen first, where it says that you can deploy this thing to Azure, and apparently on Windows Server or Linux. Well, not yet, not really. Linux they're rolling it out, but you can totally deploy to Windows Server, and in Azure it's going to work great. Again, remember, it's called the Microsoft Azure Service Fabric, right? For some funny reason. Because you can actually also deploy this to a private cloud, private environment on your own data center, or on a competing cloud. It doesn't really matter because the Service Fabric is not the Microsoft Azure Service Fabric when you look at the namespaces. It is the system fabric. So the Azure Service Fabric doesn't care about Azure. It really doesn't. It cares that it has some VMs that it can deploy to. And another interesting thing about that is that the Service Fabric itself doesn't have an SLA. And it'd be like, no SLA? What are you talking about? Well, the Service Fabric is a distributed systems platform. It's not an Azure service. You can provision a Service Fabric cluster in Azure, but what is that? Well, that is a set of VMs that gets provisioned on your subscription. And that set of VMs is a cluster which runs the Azure Service Fabric. But the Service Fabric itself is not an Azure service. It's a little bit, you know, wonky, but you get what I mean. So the SLA for the Service Fabric is the SLA of the VMs. OK, makes sense? It's good to know the difference. So if we abstract this thing out a little bit, you get, and put like big boxes, you get something that looks like this. And we're going to spend the rest of our time digging into as much of this as we possibly have time for. But it will be, you know, we have to move quickly, and we won't be able to cover everything in detail. So I want to start at the bottom and explain to you why Service Fabric works, why clustering and microservices is something that is pretty cool and gives you some capacities that you would want for your application. Remember the happy blue lipstick guy that built the features and all that other stuff that we needed? All that other stuff is what something like Service Fabric fundamentally is supposed to be able to give you as a developer, that you just want to run your thing and you want all those nice features. So here's how and why that works. In a data center, you have lots of machines, physical, probably virtual, right? If you draw a circle, you get a cluster. And again, like something like Bing Cortana runs in like 5,000 instances, right, of a cluster. So a cluster scales to a lot. So here's a little cluster. It's a small one. And let's deploy a Service Fabric. Sorry, let's deploy a microservice instance. OK, so what's this? Well, it's the red microservice here, and it has a primary. And then for high availability and failover, it has replicas, secondaries, active secondaries that are in sync. The data inside of one of these instances is in sync on all these instances. Okay? So let's deploy a few more of these guys onto the cluster. So we have a bunch of microservices. And when you deploy, the cluster, the service fabric, will look at the nodes and see how much load they have, and they will spread out automatically your deployments on this cluster, on the nodes. And you don't actually know where they will end up. Service fabric will take care of that. And OK, so now we have a problem. There was a node failure, right? This machine is gone. It blew up for some reason. We don't know why it's gone. So now we have some issues. What's the number one issue we have in the current scenario? What's the biggest problem? Yeah, it's the second biggest problem because there's a little bit of a sneaky one here. The first biggest problem is that the cluster is actually broken. So it puts itself back together again and realizes, oh crap, this machine is gone. Now the second biggest problem is correct. The green primary is also gone. So at this instance in time, I'm saying this over sentences. This is microseconds. So at this instance in time, the green microservice is not responsive. There is no primary that can receive traffic from the outside. So immediately, the cluster will see this, and it'll say, OK, so then we promote this secondary to primary. And now the service is responsive again. Now we are actually back in a working state entirely. But we are missing some secondaries, because when you deploy, you define this is how many secondaries I will have for this microservice. And you define this, and then the service fabric will ensure that you have that. But we don't right now, so it'll copy some more instances of secondaries and make new copies and fire them up to get back in balance. Now, if this is running in your data center and a machine maybe physically actually breaks, it might take a while before you replace the parts and fire up a new instance of a server. If you run in the cloud, you might quickly get a new instance. You just say, I'd like a new instance, please, and you'll get that, because there are thousands or hundreds of thousands or however many virtual machines potentially available in a data center. And then, of course, when a new node shows up, a new instance shows up in the cluster monitor will see, hey, there's a whole machine there which is underutilized. This thing doesn't have anything on it. So let's go and balance some stuff out and move some stuff around to make sure that we have an even spread on the cluster. That is how this works, OK? So regardless if it's Azure Service Fabric or some other similar technique, it's going to work pretty much the same. This is why this works. With this, you will get things such as failover automatically. You don't have to do anything. Just by using this technique, this platform, you get this for free. So again, let's recap a little bit, I guess. But let's say we have one instance here. And if there's a read request that comes into it, remember the architecture. Odds are, hopefully, that the data that one needs to be read is in that node. It's right there, this local state. So the read request is immediately given a quick response right out of memory. No latency jumping to an external store or anything like that. But just read it and respond. No cache even involved. It's right there. Now, a writes, on the other hand, an incoming write request would go and be replicated underneath the covers to all the secondaries. And then when enough secondaries acknowledge the write and go back and say, yep, got it, the write is acknowledged out. This is exactly how the one instance of your SQL database works. How many secondaries do you have on your SQL database? Yes, somebody said 2. That's correct. We all know that what we see as one database is one database with 2 secondaries. So every write we make is replicated, and when we have a write quorum, it responds and everything is all right. That's why you don't lose data inside of your database. It would be really, really bad service if, oh, sorry, we lost some of your data. That can't be, right? So this is replication ensures the high availability and the consistency of your data. So and for those of you who were observant saw that this last guy there was late, and he can come back and say acknowledged at a later time. That's fine. OK, so let's see if this primary fails, like we had in our example, right? The primary fails, just to recap, then you'll have a promotion of a secondary to become the new primary. And then if a secondary fails, well, then that fails. Too bad. So now we're still, this service is still responsive, it still works, there's nothing wrong with it except that it's not in the desired state. So let's see that the old primary, he comes back. He didn't actually die, he just had a hiccup. He comes back, and now you have this split brain scenario. He comes back and says, hey, I'm the primary, awesome, let's do this thing. And the actual primary will say, nope, sorry, you're not the primary anymore, you are demoted to secondary, and oh, by the way, catch up to what we've been doing since you've been gone. Okay? And then, of course, the thing I showed you also earlier, you can go and bake and create and build a new secondary and slide that into place. So that's how that works, and sort of, you know, but wait, there's more, right? This is the stuff you get kind of for free for using something like the Service Fabric distributed systems platform thingy. Pretty cool. Yes? Nodding heads. Awesome. Good, good. So that's the lower end of things, and I won't spend any more time there. I've sort of explained why this works. So let's go up instead and talk about how you actually interact with this. How would you build an application that interacts with the Service Fabric and that stateful storage thingy? How do you do that? Well, you could run any arbitrary exe as an instance of a microservice. You could run an ASP.NET application if it's, you know, self-contained, something like, you know, yeah, well, anyway, you know, this is going to run with the .NET Core and stuff like that. So anything that is self-contained and can run on the machine is your Service Fabric instance, or sort of microservice instance. But if you wanted to interact with the API, that stateful storage thing, of course, then there's an API, there's the Reliable Services API, and the Reliable Actors API. So looking at these two guys, the Reliable Services API allows you to build stateless services using existing technologies such as ASP.NET, or stateful services using reliable collections. We'll talk about what that is. And then you can manage the concurrency and granularity of state using also built-in transactions. I'll show you. And communicate, of course, with anything else on the outside. This is a process that runs. You can do whatever you like with it. Okay? So reliable collections is very interesting. Very, very interesting. Going back to the history of collections, we started out some time ago with having a single machine, single-threaded collections, and then the evolution of that was to make the collections multi-threaded and still work. So that's what we've had. Reliable collections, though, is a multi-machine collection, which is replicated with high availability, gives you persistence, it's durable, it's asynchronous at this point. You have to do this asynchronously because we are, again, doing this right. We are replicating our writes to other machines. Hence, it must be asynchronous but in nature, the interaction you do with this. And transactional. So that's what you get with these reliable collections. And we're going to look at that real quick soon. So let's go first to, just to show you, if you do a file, new, I'm going to show you the different pieces that are in there. It's going to be cloud. The resolution always gets you, right? So let's just do that and say, OK, just to show you the dialog that comes up. These are your options that is it big enough? Yes? So you get all these options of things you can build here, right? You have ASP.NET Core there, guest executable, and then you have your stateful and stateless services and the actor thingy. So these are your options or templates that you can do. Okay? Just wanted to, like, there's no magic there or anything. That's going to give you a little project. Right. I actually coincidentally closed the one I wanted to have open. It was that one. So, and in Azure then, I did a couple of screenshots because, you know, Wi-Fi and internet connectivity is sometimes flaky, but I think it might work here now. When I go and create, I just want to show you this first because that's not something I'm going to show you in the portal. When I go and create a cluster in the portal, I say I want a new Service Fabric cluster. I go and configure that and set that up however, you know, I want it. And of course, during the creation process, I can extract a template, an ARM template for Azure Resource Management, which will provision this whole thing. There's a lot of machines in there, a lot of moving parts, and there's networking and stuff that's being set up for me automatically. And the image that we are imaging up, that we are newing up when we create our instances of machines in our cluster, have the Service Fabric on them. So that's what we get. So let's go to the portal. And I created, actually last night, I started up an NDC Sydney Service Fabric cluster instance, which runs in Azure right now. And hopefully, let's see, the internet and things. I'm happy that I have the backup of my, my screenshots. So there we go. Here's my little cluster. I created that one just for you guys. Oh, isn't that sweet? With 5 instances. I believe I picked the smallest possible machines. I didn't configure security or anything. I just, this is just a throwaway kind of thing to show you guys. So it has 5 healthy nodes. You have different upgrade domains and fault domains and such, you know, all the good stuff that we already know about Azure, and that's all configured and set up for me. And I also have one application that I deployed. It's basically a file new-ish kind of application, but I just deployed one to show you guys. And I can go actually inside of Visual Studio and do this. Here's my stateful application. Let's zoom in on that. Here's my stateful application type. This is like a cloud service package similar to. It's just the thing that configures and defines what your application is. And then down below, we have the actual project, which has a program class. This is a console application, gentlemen, right? And ladies, a few, yes? This is a console application. That's what that is. And inside of this, I have something called a Stateful Services demo. If I jump to that, it is inherits from Stateful Service. So now we're talking to the SDK, and the reliable services SDK of the Service Fabric is what we're talking to now, right? So this is a Stateful Service, and let's actually remove. Before I do, I'll just show you that. Yes, I can interact with my Azure Explorer, Cloud Explorer. I can interact with my local cluster, with my cluster in the cloud, and that's all good, right? So I'm going to F5 soon, and we're going to deploy to our local cluster. Actually, let's F5 now while I'm talking, because it takes a minute or a little while to deploy. So I can run local development on my local machine, of course. I mean, this, after all, this is Visual Studio. This is Microsoft. You would expect that. But unlike cloud services, when you do local development, that was another implementation, a version of the stuff that runs in the cloud. The Service Fabric scenario here is that I have a local cluster that I can fire up on my local machine for dev purposes, and that is not another version. It is the same code, which then runs on my machine that you would run, that will run in Azure or anywhere you want to run your cluster. It's the same code, and that's pretty cool. So this it takes, when you F5 this thing, unfortunately, I think it's kind of slow, but it works anyway, and you can debug, and you can attach to a process, a microservice running in the Azure cloud as well if you want to do that. And all these things that we would expect Microsoft to deliver when they build something, you know, tooling for Visual Studio, all of it's there. So let's quickly look at our little method here called run async. Is where that's where the action happens inside of this thing. You can see here that I'm starting to interact now with the, is it too small? A little bigger? No? A little bigger, yeah. Oh, let's see. See if we can do it this way. Yeah, cool. So you can see here that I have my state manager inside of my stateful service, my state manager, and from that guy I can request instances of these reliable collections, an iReliable queue, iReliable dictionary. I can request these instances, these highly available, scaled out instances that I pull out of my state manager, right? So then we have your classic while true loop. While I'm not canceling this, how's about I make a transaction? So I go and say I want to do a transaction inside of my state here, and I want to interact with my queue, my dictionary, my other dictionary, and so on and so forth, and do things with these guys inside of the scope of one transaction. And then at the end of that transaction, I can commit or abort whatever changes I made to my state. Unlike if you would build the same solution with an Azure SQL Database and an Azure Storage Queue, those two would never share a transaction. Those are different services in the Azure platform. They would never have the same transaction. So you can see how this simplifies things and also makes it quicker because there's no latency for jumping to a different service. So if you can solve whatever business problem you need and have your data here, then you probably should. But you should also back that data up on a database. Sure. Cool. So that's how that works. Any thoughts on that? Questions? Yeah.
Independent development. I mean, can you have a model where you're developing your traditional web APIs or DLLs with some logic, etc., and use Service Fabric only for orchestration?
Yes.
It's just that this, from an architecture perspective, we're known not to create dependencies on platforms much, and this feels a bit.
So this is a dependency on the platform. Now you are depending on the Service Fabric because you are building a Service Fabric service. There's no requirement to do this. You can run your web API. So the question is, can I run can I build stuff without this? Of course. You can deploy any arbitrary exe, your ASP.NET Core application, and just use the Service Fabric platform for orchestration and for failover and for high availability and that sort of thing. You can do that. You don't have to interact with the SDK. You can choose to interact with the SDK if you want to have this. The queues and the dictionaries that you can use inside of one transaction, the data that you have highly available on there, and so on and so forth. This is a choice you make, a trade-off. If you want to tie yourself closer to the Service Fabric, then you do that. But Service Fabric, again, this is available for you to just use. There's no charge to use it, and you're not constrained to where to deploy this. So you choose. Pick your poison, basically, right? So this is very similar to the olden days when we, and of course cloud services, just to be very, very clear, cloud services is not going away anytime soon. It has its place, and a lot of deployments are running cloud services, but it's similar to exactly that scenario where you would choose to make a dependency on cloud services. But this is much more open than that because you can deploy this anywhere, right? So it doesn't constrain you as hard as cloud services did. Okay, cool. Great question. Awesome. Right, so here's my backup slides. I showed you local development. Oh, I did actually push F5, so let's go back to our local environment here. There is a little Service Fabric cluster manager down there in my system tray, which I can click on, and when I do, which I already have done, I get this. You see here localhost, says localhost. I get the Service Fabric Explorer, where I can see that I am now currently running one application on my cluster, and my cluster has some system services there. These are instances of microservices running inside of the cluster that actually manage the cluster. So they run their own system services as instances inside of the cluster as well. So you have your naming service, your fault analysis, failover manager, cluster manager services. All these things run in the Service Fabric, and your application will also run in the Service Fabric. So here's my little demo thingy. It's there, it's available, it works. And when you dig into this guy, you can see that it is running on the primary node 2. So it has the primary on this node. There's my instance. I can dig down to that. I can get all the way down to here's the code that actually runs. Here's the package, the version of my code that runs on this thing for this version of this thing. Okay? And again, like I said before, this thing has an address. You can address this. It's, in this case, fabric : service stateful application type. It would be more complicated if you have that in the cloud. And speaking of having that in the cloud, this Service Fabric Explorer, again, is running on my local box. And here's the other one running against my cluster in Azure. It's the exact same thing, Okay, so no magic, no strange thing, the exact same code, the exact same thing. Okay? So local development and reliable services API, I already showed you this. So let's talk about actors. There's also a virtual actor programming model that you can use. If you have applications with multiple independent little units of state in compute, you can use the actor model. It gives you state management, it gives you term-based concurrency. There's a single-threaded execution thing that it runs under. And this model, just really on the surface now, guys, because we don't, we can't spend too much time here. If you have an I actor called, in this case, Hello World, you define that, and then you implement that actor interface. You derive from the actor base class, and you create your implementation, and then you register your actor implementation in your in your application type. Register that. I'll show you that, and then you can create instances of this actor implementation. Okay, that's literally how that works. So let's go. I have another a small counter demo, which has again similar to before. It has a main. Oh, this is too big. A little bit smaller, a little bit smaller. There we go. It has a main where I register my actor inside of that. And my actor implementation, if we jump to that, is, like I just showed you on the slide, derives from actor, implements some kind of an actor interface. And then I can do things when it's activated. I can create messages in my event source, for instance, say that this thing is now activated. I can set a counter. That's the one method that I have on my interface. I can update a counter with this, and I have my state manager in here where I can interact with state inside of my actor, and I can have persistence models for this, and I can choose to persist this in a document database or somewhere behind the scenes. So that's how that works. It's a very small demo, but it gets the job done. I did do one thing that I just couldn't help myself, because I want to point out that here's the actor, my actor interface, which I have, and it derives from iActor, but it's also an actor event publisher. So when I do the set count async call, inside of that implementation, I actually have also an actor event which will fire and say count updated. So I can be connected to this thing and have something else somewhere else, a client somewhere being updated when something happens on the actor on the server. So I can have events firing. Yes?
Is that buffered or is it sort of synchronous?
That's, I would say, I think that's synchronous. I don't know, I think it is. It sets up a connection for you, so you can from a client application, you can connect to this thing and get a proxy instance of that and subscribe to that event on your client application, and it would fire up in the cloud somewhere and inform your client about this change. Sure. So we have that now, okay, so actors. It's really, I'm brushing through that really quickly. I have like one more thing that I want to talk to you guys about. Actually, this is going really fast. so we have plenty of time for Q&A and thoughts at the end here. That's good. I have an anti-pattern that I really like. It's the almost flying in the clouds anti-pattern that I invented. It's when you build something and you don't go all the way. You want to build a new application, you want to move forward and jump into this cloudy thing, but you kind of keep one foot on the ground, right? Just to be safe. And there is this world that you come into, and I mean, it's a valid objection, right? Do I have to buy into all of this, or how much and at what pace, and what is the stance that I should have here? I would venture to say that if you're going to build something new today, it's very, very likely that you could benefit from a microservices scenario. It's kind of all the rage right now, but obviously you should also look at this, the functions stuff, right? Whether it be Lambdas or Azure functions, Serverless is also pretty cool, because then you wouldn't have to have a cluster if that's what you need. But the risk we have here is that we are almost flying in the cloud. So we deploy our things. Sometimes that's the right thing to do. I don't want to tie myself to the Azure Service Fabric. Your question or your thought there previously is the perfect example of this. There's no right or wrong. There's a choice. And you can choose to stay away from maybe tying yourself to the SDK of the Service Fabric. You can choose to do that. At what cost is the question, right? If you can make your application architecture very much more simple by possibly even being able to remove a few databases or some caches from your solution, it's going to be cheaper. There's going to be less pieces that could fail, and you might get the same job done quicker. So what is the trade-off cost? What are you willing to do or not do to get the job done? And again, there is no one answer here. Each application would have its own scenario and its own benefits or anything. But you have to think about that. How much pain are you willing to put yourself through in order to almost fly in the clouds? You want to be that guy who falls down? Well, it's up to you. It's up to you. Looks really good when he starts off, right? And then after a while, you'll know what happens. And now when it comes to servers, I think many of you have seen this or quote or this statement that when you have servers, you don't want to treat your servers like pets, because if one of these guys dies, if we kill one of these, and which one should we go with? Which is ugly? Did the pug? Did we kill that one? Yeah. If you kill that guy, it's really sad. I mean, we'll be heartbroken because we don't kill that guy because we'll miss him. We take care of him and we pet him and we give him food and we nurture him, and that's so nice, right? So we don't want to actually have this set up anymore. What we want to do is we want to have a pack of wolves. You thought that was going to be cows, right? I think cows are stupid, so I went with packs instead. Okay, so we want a pack of wolves. We want a cluster of identical machines, and when you kill one of these, there's a new one's going to step in and take over. No problem. It's going to be identical and it's going to work. So no maintenance of OSs and no other, no such thing at all. We deploy the Service Fabric in this case and our microservices inside of that. And if we want to upgrade or change a machine, no problem, right? They are all identical in this scenario. They are not our pets anymore. That's what we want to have, and that's the big trend that we're seeing and has been seeing for a while. But I know, of course, many of you guys in here know intimately about this, and you're here to listen to specifically what the Service Fabric is about. But I work as a consultant myself, and I see a lot of companies that haven't got a clue about this at all, haven't looked at this at all, anything. So, but it is, so while some people consider that not to be a very new trend, it's extremely new to some other people, I'll tell you that much. If you want to party in the cloud, there are party clusters that you can go to. I just want to point that out. aka.ms/try Service Fabric. You can go there, they fire up clusters that they keep around for a while, and you can just create a little application and deploy that to these party clusters just to try it out and see if it's fun. So Microsoft run these little clusters for you. And there's actually a very good point to be made here. Service Fabric, when I provision Service Fabric in my subscription, I get a set of VMs, right? And these are now my VMs that I need to keep running and potentially upgrade and such and such. I really want to have, hey, I wrote this microservice. How about you, Microsoft, run that for me? Right? A fully hosted version of this. Of course, there's a fully hosted version of Service Fabric coming, but I know for a fact right now that a lot of people are also running Service Fabric or starting to run Service Fabric outside of Azure. And so there's a focus on that currently, but there will come, of course, in a future, a version where you just show up with your microservice and there you go. And you don't have all of these instances of machines inside of your own subscription. So there is, is that IaaS? Is that PaaS? Well, let's think about that for a while. Currently, it's kind of IaaS-y in some respects because you have your own VM still. But they are wolves, not pets. So, Q&A, folks, before I wrap up. Any additional thoughts or questions? Yes, sir. Oh, we have a microphone. Cool.
So can you also cover about how do you hydrate and dehydrate the collections?
Oh yeah, yes. Hydrate and back up the collections, the state, the storage. Yeah. So there is a backup and restore function in there for that, so that you can do backups on that state. But you would also probably have another process that ships that data off to some more other durable storage, like in Azure Storage Table or blobs or a SQL database.
So the question was, is it more out of the box? Is something available out of the box for me to hydrate,
yes.
Or will I have to hydrate it myself?
Well,
doing something.
I think you would have to interact with the cluster with your service to say I want to back up now, I want to restore from this restore point, and so on and so forth. So you can back up and restore the state. It's possible to do, but you have to do it. Okay.
Thanks.
Right. Thanks. Question in the back.
With the stateful services, how does
Yes.
that typically look for an application upgrade?
So with the stateful services, how does that look for an upgrade? It's a great question. You mean like with when you change the structure of your data in the
Exactly.
state?
Yeah.
Well, that problem hasn't been solved yet, right? It hasn't been solved for any other scenario either. If you have a breaking database change, and if you roll that forward, if you roll that back, what's going to happen? I'll say one thing though. Of course, this is not an easy thing to solve. Breaking changes in your data structure is always challenging, and it still is in this scenario here. You probably need to do a multiple upgrade, one that goes to like a version 1.5 and then change the data and then go to version 2. And it sucks, but it's still true. And while I'm saying that, there's one other thing which is important here. In this deployment process, when you deploy an upgrade to a service, we haven't really talked about upgrades and deployments in this presentation. We have a few minutes, so I can briefly touch upon that now because of this context of the question. There are some levers and stuff that you can set, some tolerances that you can set when you deploy an upgrade. And things such as responsiveness and things like that. And if you set that up right and deploy a new version of a microservice to upgrade, do a rolling upgrade and take over your old instances with a new version of this, that's automatic, of course. When that rolls out, if the Service Fabric discovers that all of a sudden maybe you made a mistake, or no, not you, somebody else made a mistake, and now you're deploying this thing, and Service Fabric notices that, hey, this thing is not responding the way it should anymore. This is not right. Odds are actually quite good that it will stop. It'll inform you about this, optionally even roll that back without you doing anything at all. So in this, there's this whole thing with the upgrades, and we didn't have time to cover that. But yes, that's in there as well. Long story, long answer, and partially not what you asked, but.
But I can imagine that gets complicated with data as well, right?
Yeah, and it always was, and the person who solves that will be infinitely famous because no one has solved it yet. Still true that it's not solved. Great question. Yes, a question up front. Awesome questions.
Just wanted to ask about the load balancer and how it worked.
So
let's say we've got the fabric, it's got some microservices, but we want access through consumers outside the fabric. So we've got a fabric running in our enterprise on-premise, for example, or fabric running on Azure, and we have a third-party consumer now that's going to consume through the fabric. We found a limitation, and I just wanted to confirm if this is a limitation or not, that if we are going through the load balancer from the outside into the fabric, then we have to have the microservice instance that we're trying to access deployed on every node. Otherwise, the load balancer doesn't know where it's actually deployed.
Ah, okay, I haven't heard about that. Sounds weird. I don't know, that's a very specific scenario that I haven't come across that issue. Again, the problem here is that I don't work for Microsoft, so I couldn't give you a Microsoft official answer on that, unfortunately. I haven't heard that problem.
But have you seen public APIs deployed through the fabric before?
Oh yeah, very much so. People deploying API applications. Absolutely.
Multiple of them.
Oh, sorry?
Multiple of them on the same fabric.
Yes, I've seen
and
that.
accessed from the outside?
Yes.
Cool.
So there's something wrong with what you're saying. There must be something screwed up somehow. I don't know how. Okay. Strange. Maybe we can talk about that more later outside. So we have a few more minutes. Yes? No? Yes?
Just you talked about the upgrades. In your experience as a consultant, has that worked well, the upgrading the applications using the upgrade mechanism?
Yes. Yeah, and I'm thinking if there's more to say there. So far what I've seen is that it's worked well. Yes, it has. I haven't done a lot of this configuration stuff that I talked about. My scenarios have been fairly simple at this point, and it's still because of early days and such, right? People are getting warmed up and learning how to do this thing, and in that context, I haven't done really complicated scenarios yet with data changing and that sort of thing. I haven't done that much. It is the challenge of newer technologies. This is a GA product since almost 6 months now. It GA'd at Build this spring. But again, how many of my customers are actually using this in production? Well, not many, not yet. So there is that lack of actual projects, unfortunately, a little bit. Yeah. Lots of questions. Awesome.
How large can we have those reliable collections?
How large?
Yeah.
Yeah, so the size of that is there's this whole thing that you need to go into when you start calculating how much size does whatever you do take up on the cluster. When you provision the cluster, you choose the size of your machines. You can actually have multiple sizes of machines, but typically you will have if you have a normal cluster, it'll have one size of machine, and you decide how big that machine is. And that will give you a certain amount of disk, a certain amount of memory, and a certain amount of everything, right? And then you have that as your resource. And then you need to start to calculate how many instances of which microservices will I run, how many replicas will those have, because if you have a primary with a gigabyte of data, your secondary would also have a gigabyte of data on a different node. So how long until you saturate your cluster and have to actually make it bigger to accommodate the size of your data and so on and so forth. So there's this whole calculation thing that needs to be happening there. And you'd probably not just have one microservice, you might have multiple, and these might have multiple instances of each and so on and so forth. So you have to start doing some maths there. But it's a math problem, and it's not extremely difficult. It's additions and subtractions, so it's not horrible. Maybe a bit of multiplication as well. Does that answer your question? It's constrained by the size of your machines.
Yeah. I have a question. If we have to set up staging in prod environments, do we have to do it ourselves, or do we get something out of the box?
I'm sorry, the question?
I mean, different environments, staging, prod.
Oh, yeah. Oh, that is a great question. I like that question. So if I run one cluster, it's perfectly viable to deploy my potential. I mean, imagine this, right? You can deploy your development environment and your production environment instances of your microservices to the same cluster. It's absolutely possible to do. You just give them different versions and deploy them as different deployments. They can run side by side. It's a little bit odd, but it's possible, especially when you start out. A couple of customers of mine have done that. They start out really small. So they just don't want to have a lot of, they haven't filled up a cluster yet. So the step into this is going to be slightly expensive for everyone. So this is not for everyone. I mean, if you have just one instance or two instances of servers that you need to run, this is too big. This is at least maybe 5 machines, right? So this is maybe probably something along the lines of at least 10 cores to get this thing running properly. It is a big step in. And when you start out, you're not going to have filled that up and you have one little microservice in a whole cluster. That's going to cost you more than it's worth in the beginning. Down the line, that's going to reverse again and it's going to pay off. So initially, obviously, deploy both of them to the same environment. Why not? But then you can also maybe not do load testing on that same cluster. The cool part is, though, that you would have your template and you can just deploy any cluster, do load testing on something there, and then delete it again because it's Azure and that works. And then maybe in a future, if or when you're big enough, you might have one cluster for development and another cluster for production. Does that answer your question? Good. Right, we're about to run out of time. I'm going to wrap up real quick. You can go and find that online, yes. Microservices trend. It is pretty awesome. We're going towards it, and there's no denying it. We're right there. I would say that Service Fabric is pretty amazing. Sure, I mean, anything has its ups and downs. Talk to you outside if you want to have some. No, kidding. PaaS v2, call it what you like. I don't care what we need to call it. Is Service Fabric PaaS v2? Is it scales, VM scale sets that's PaaS v2? I don't care, really don't. But it is, there's a lot of interesting stuff happening in compute, and I hope this has been interesting for you. I hope you've had, you know, some new information coming your way here. I appreciate you taking the time to be with me today, and you should now go about your rest of your conference and enjoy it. Thank you very much.